Welcome to World Prism. Please subscribe and hit the bell icon for more breaking updates. For decades, high-speed rail was dominated by Germany and Japan, two nations whose engineering prowess and relentless innovation set them apart from the rest of the world. Their trains weren't just fast, they were symbols of national pride, technological ambition, and a vision for the future of transportation. The Shinkansen and intercity express trains became global icons, setting the standard for speed, safety, and reliability. Their influence stretched far beyond their own borders, inspiring rail projects on nearly every continent. These countries exported not just trains, but a complete ecosystem of railway expertise. Their influence was felt in the nuts and bolts of railways worldwide, from the critical components, wheels, signaling systems, bogies, to the software that kept trains running on time. German and Japanese technology powered rail networks from Europe to Asia, Africa to the Americas. But in late 2024, a subtle shift began. Both nations started quietly restricting exports of their most advanced railway technology, especially the innovations that gave them a competitive edge. The move was particularly aimed at rising competitors like China, whose rapid progress in high-speed rail had begun to unsettle the established order. German firms began to prioritize their European partners, focusing on strengthening alliances within the continent and ensuring their technology stayed close to home. Meanwhile, Japanese manufacturers shifted to offering full-service projects, design, build, operate, and maintain, keeping tight control over every aspect of their technology and expertise. This wasn't an act of hostility, but a calculated, strategic move. The logic was simple: why sell parts and risk losing your edge when you can sell the entire system, bundled with lucrative service contracts and long-term partnerships? By controlling the whole package, German and Japanese firms could ensure ongoing revenue and maintain their leadership in the global rail industry. The impact was immediate and profound. China, which had long relied on German and Japanese components to guarantee the reliability and safety of its rapidly expanding network, suddenly found itself facing a new and unexpected barrier. Factories that once hummed with activity now faced shortages, and engineers scrambled to find alternatives as supply chains tightened overnight. The era of open technological sharing was drawing to a close, replaced by a new age of guarded secrets and strategic alliances. The old guard was tightening its grip, determined to protect its legacy and reassert dominance in a world where the race for high-speed rail supremacy was only accelerating. Across the Atlantic, the United States watched with a mix of satisfaction and mockery, especially toward China. American commentators claimed China's rail boom was built on borrowed technology, predicting that without German and Japanese parts, China's ambitions would stall. News networks and social media painted China as exposed and dependent, while touting America's own freight rail as a different kind of success. The taunts were sharp. How could China lead in tech if it couldn't make its own advanced train systems? For Washington, this was a moment to reinforce the narrative that China's rise was unsustainable without Western innovation. But this mockery underestimated China's drive for self-sufficiency. While the world doubted, China saw not a crisis, but a catalyst. The world waited for China to falter after the supply chain squeeze. Instead, in autumn 2025, China unveiled the Fuxing Kaiyuan, the world's first fully autonomous, mass-produced high-speed rail system powered by magnetic levitation and graphene polymer composites. This was a quantum leap. Lighter, stronger trains, stable at over 650 km/h, and fully AI-controlled. German and Japanese components weren't just replaced, they were rendered obsolete. 3 major new lines were already operational, revealing years of secret R&D. China's state-driven innovation had built redundancy and, ultimately, superiority. The world's mockery turned to shock as China leapfrogged its mentors. China was no longer a follower, it had set a new global benchmark. The game had changed and China was now leading it. Japan didn't panic in the face of China's leap. It doubled down on its strengths, precision, service, and practical innovation. Japan's privatized rail system focused on continuous improvement, not headline-grabbing revolutions. A prime example, the world's first 3D-printed train station, built in hours to address labor shortages and costs. This wasn't about speed, but about resilience and efficiency, values central to Japan's rail philosophy. Japanese firms like Sumitomo shifted from building railways to operating them, embedding expertise in global projects for long-term influence. Japan's approach is 1,000 small optimizations, not a single breakthrough. By focusing on operational excellence and global partnerships, Japan is carving out a powerful, sustainable niche. There's more than one way to lead in the future of rail. For decades, Germany has been the gold standard in rail engineering, setting benchmarks for speed, safety, and reliability. But after China's maglev breakthrough, the landscape shifted dramatically, presenting Germany with a new set of challenges and opportunities. China's rapid development of maglev technology, which bypassed traditional export restrictions, signaled a turning point. The world watched as China leapt ahead, sidestepping barriers that once protected German dominance in the global rail sector. Rather than entering a costly race for maglev supremacy, Germany made a strategic decision. They chose to refine and perfect their conventional high-speed rail systems, focusing on making them more energy-efficient, digitally advanced, and environmentally sustainable. In Europe, where the rail network is vast and interconnected, radical overhauls are difficult. German firms recognized that smart, incremental upgrades like modular train designs and advanced digital control systems would deliver the most value. Their ambition shifted to become the indispensable partner for modernizing Europe's rails, collaborating with neighboring countries and leading the way in infrastructure renewal, even if they no longer held the title of the world's fastest train. Germany's enduring strength lies in its powerful industrial base, its skilled workforce, and its global reputation for precision and quality, qualities that remain in high demand. The shock from China's rapid progress forced a strategic rethink. German rail shifted its focus from headline-grabbing spectacle to robust, sustainable solutions that address real-world needs and long-term environmental goals. In a world of evolving technology and complex markets, Germany's relevance endures, built on practical innovation, adaptability, and a commitment to shaping the future of rail for generations to come. The United States is a paradox, home to the world's largest freight rail network, but decades behind in passenger rail. While American companies dominate logistics, high-speed passenger rail is nearly absent, hampered by politics, car culture, and geography. Attempts at high-speed rail, like California's, have stalled amid delays and infighting. America imports rail tech for freight, but isn't a player in passenger innovation. China's maglev leap made America's passenger system look outdated, widening the gap. The US is a superpower in most fields, except the one now critical for sustainable urban transport. Without a national commitment to modern rail, America risks being left behind as the world speeds ahead. Over the past year, a new kind of global competition has emerged, one that's not fought with armies or weapons, but with rails, speed, and innovation. This is the dawn of a railway war, where nations vie for technological supremacy and economic influence, reshaping the balance of power in the 21st century. China's maglev leap has shattered the old order, propelling the country to the forefront of high-speed rail. Driven by state ambition and massive investment, China is setting new records and exporting its vision worldwide, challenging the West's slower evolutionary approach to progress. Meanwhile, Japan is doubling down on pragmatic, cost-effective innovation. The Shinkansen's legacy of safety and reliability is now paired with a focus on long-term partnerships and sustainable growth, making Japan a quiet but formidable force in the global rail race. Germany, at the heart of Europe, is investing heavily in optimized, interoperable rail systems. By connecting diverse nations and technologies, Germany is building a network that can handle the continent's complexity, aiming for seamless travel and digital integration. In contrast, the United States faces a stark wake-up call. Its absence from the high-speed rail revolution is becoming a growing vulnerability, as outdated infrastructure and stalled projects threaten to leave America behind in the race for future mobility. This intensifying rivalry is sparking a wave of innovation across the globe. Nations are pouring resources into research, infrastructure, and new technologies, determined not to be left behind as the world's railways evolve at breakneck speed. China's breakthrough is already inspiring new research in Europe and Japan, and may finally galvanize US action. The race is no longer just about speed, it's about who will define the future of transportation and reap the economic rewards. The tracks being laid today are more than just steel and concrete. They are the pathways of 21st century power, connecting cities, economies, and people in ways never seen before. As nations race to build the fastest, smartest, and most connected rail networks, the entire world stands to benefit from this new era of progress and possibility.